Hello, my name is Tiffany, and in this video, I will be walking you through my SVM classification analysis using Python. This project uses customer demographic data to predict whether the customer will purchase a latte and a donut together during a transaction. I'll briefly explain the purpose of each step of the code and the overall workflow and some of the insights and challenges I encountered during this assignment. To begin, I imported all the necessary Python libraries, including pandas, NumPy for handling data, sklearn for machine learning, matplot library for visualization, and the KDS for performance plots. These packages provided tools that I needed to clean the data, train the model, and evaluate its accuracy. From here, in steps 2 and in steps 3, I set up my working directory to the folder containing my Jupyter notebook and Excel file. And from there, I loaded the train test data sheet from the lattes 2 Excel file into the pandas data frame. This data set includes age, estimated months as a customer, estimated salary, and the target variable, latte donut. I checked the structure of the data set and I reviewed the distribution of the target variable, and to make the classes were balanced, though, to train a stable model. Next, in steps 4 through 6, I selected the 3 feature variables and separated them from the target using the sklearning train test split. I split the data into 70% training and 30% testing because this helps ensure that the model generalizes well and is not simply memorizing the training data. I also applied a standard scaler to the features, which is important because the SVN models with the RBF kernel perform much better when features are standardized. In steps 7 through 10, with the data prepared, I created the SVN classifier using the RBF kernel. I trained the model on the training data, and then I used the cross-validation with the 4 folds. My cross-validation accuracy was in the mid-80s range, which was a good indicator for stability. Then I predicted the labels for the test set and reviewed the confusion matrix. The model performed well, correctly identifying most positive and negative cases with very few false positives. In steps 11 through 14, the KDS package generated multiple plots, including the lift plot, the cumulative gains plot, the decile wise lift plot, and the KS statistics plot, which are all in here. These confirm that the model separates purchases from non-purchasers effectively and ranks customers in a meaningful order. My KS statistics was over 66%, which is considered excellent. I also created an ROC curve using the predicted probabilities, which produced an AUC score of about 0.85, showing strong discrimination between classes. Using the sklearns metrics, I also calculated accuracy, precision, recall, F1 scores, hammering loss, Jaccard scores, log loss, and the Matthews correlation coefficient. all reinforcing that the model performs well. Then in step 15, I finally imported the new customer data set, removed the record column, and scaled the features, and used the SVM model to predict whether each new customer is likely to purchase a latte and donut. These predictions were added back into the data frame and exported as a Excel file called lattes2 predictions over here. Challenges and what I learned from this assignment, one of the things that I encountered was that the KDS library did not support a parameter, so I removed it to avoid errors. I also learned how important feature scaling is for SVM models, especially with the RBF kernel. Another key takeaway was the value of performance plots like lift curves and KS statistics. They provided business-friendly visualizations that helped me to interpret the model beyond accuracy alone. Overall, in this assignment, it strengthened my understanding for SVMs, evaluation metrics, and model interpretability. The final model performed well and provided useful insights for identifying customers likely to make a bundle purchase. Thank you for watching.